Okay, hopefully everybody can hear my voice. And if they can't, hopefully they're trying to get the sound working. This is the first lesson out of the Chapter 3 study guide. This is a lesson on Chapter 3, Section 1, Part 1, otherwise known as 311. Now, parallel lines are something you've probably seen before. They are lines that never cross each other because they maintain the same amount of distance apart as they travel across the page. Skew lines are lines that are not going to intersect, means they never cross each other, but they're not on the same plane. So, for example, if I drew a line on this piece of paper, and then I went to the back and I drew a line on that piece of paper, those two lines are not going to cross each other, right? It's because they exist on two different planes. One's down here and one's up here, right? They're not going to touch. So, skew lines are lines that do not intersect. And are not on the same plane. So for example, you look at this box, so you had a line drawn on this side of the box and a line drawn over here on that side of the box. They wouldn't intersect and they're not drawn on the same flat surface, so they would be skew lines. This edge up here, WZ, and this edge down here, RS, those would be an example of skew lines because WZ and RS are never going to cross each other and they're not on the same flat surface. RS is part of this plane and WZ is part of these planes. Different plane connection there. Parallel planes. Parallel planes are planes that are parallel. I know I'm not supposed to use the the words in the definition to define the concept, but I think you get the idea. If you have parallel lines or two lines that never cross, usually when you have a perfectly rectangular box, the planes that are opposite from one another are usually parallel. So the top of a box and the bottom of the box are parallel planes, or this side and that side of the box are parallel planes, or the front and back of the box are parallel planes. So hopefully you get the idea. Alright, so going back to this box idea, are lines WZ and ZR, are they parallel? No, WZ and ZR. Are they skew lines? Well, skew lines never cross each other and they don't exist in the same plane. These do cross each other, they intersect, and they're both part of the same plane, so they couldn't be skew lines. Are WZ and ZR perpendicular? Ah, yes. These two lines come together to form a right angle, and so I'm going to say they are perpendicular. WZ and ST. Okay, so I have this line up here and that line down there. Well, they seem to be moving in the exact same direction, this bottom back edge and this front edge, and they continue to stay the same distance apart, right? So that would mean that they are parallel. QT and YS. Well, they are not going to cross each other, so they couldn't be perpendicular. They're not moving in the same direction, so they're not parallel. So, are they skew lines? Do they exist in the same plane? No. Are they never going to intersect? Yeah. So, those are the two characteristics of skew lines, that they're never going to cross each other, and they don't exist in the same plane. So, these two lines are skew lines. Now planes can have these qualities as well. You could have parallel planes, you could have perpendicular planes, you could have skew planes. So WZR, that's the front side of the box. And plane SYZ, that's the right side of the box. So how are these two sides related, the front side and the right side? Well, they do intersect with one another, so they can't be skew lines. Are they going in the exact same direction? No, they're not parallel, but they are perpendicular. We're assuming this box is a standard rectangular box, so that means each one of these corners, where any two walls of the box, sides of the box come together, would be 90 degrees. So the front of the box and this side of the box would come together at a perfect 90-degree angle if you looked into the box from the top. So they are perpendicular. Let's see. Plane RQT. Well, that's the bottom of the box. And plane YXW, that's the top of the box. So the bottom of the box and the top of the box. Well, they seem to be moving in the exact same direction. They're just separated by space. So those two would be parallel. Okay. On the next section, we're making a list. They're asking us to find lines that are parallel to EH. EH is this one. So lines that are moving in the same direction as EH would be FG, DC, and AB. Those three lines are the three lines on edges of this box that are running in the exact same direction as EH, and they're never going to cross each other. So they're parallel. Lines perpendicular to EH. Okay, that means that they intersect at a perfect 90-degree angle. I see two. Here's EH. This edge right here, line EF, is perpendicular to EH, and this line back here, HG, or you can call it GH, whatever. Either way, same line. That's a G right here, GH. Lines skew to CD and containing point F. Okay, so CD is over here. We're looking for lines that are not going to intersect this line and not be in the same plane. So any of these lines over here in this side of the box or the top of the box are out. So containing point F. Well, F only has three lines coming out of it. Line segment FG, or line FD, and line FE. Now, FG would be parallel to CD, FD would be perpendicular to CD, so the only one that's skew would be FE. It doesn't lie in the same plane as CD, and it's never going to intersect it. Planes perpendicular to AEH. Well, AEH is the bottom part of this box, and perpendicular planes would be ones that meet it at a 90-degree angle. So I would say the front and back of the box and the sides left and right on the box would all be perpendicular to the bottom of the box because they all come down and meet it at a 90-degree angle. So my answers for number 9, I'm going to write these over here. Plane FEA, that's the front. plane GHE, that's the side. Remember, you can pick any 3 letters in a plane to name the plane. The back of the box I'm going to call HBC, plane HBC. And the right side of the box, let's call it plane ADC. Okay. Number 10. Planes parallel to FGC. FGC is the top of the box. So the only plane that would be moving in the exact same direction as the top of the box would be the bottom of the box. So for number 10, I just have to give a name for the bottom of the box. Let's call it plane ABH. That's the only answer for number 10. Example 1. Can you find lines that are parallel to AF and containing point E? So AF is the line that forms the top of this figure, the peak, and lines that are parallel to that one would be EJ, DI, CA, and B, I don't know what this letter is back here. So of those 4 other lines being parallel to AF, the only one that contains point E would be this one here. So I'm going to say my answer to part A is line EJ. Lines skew to AF and containing point E. Okay, well AF, lines that are skew, meaning it means that they don't lie in the same flat surface, and they're never going to intersect with it. So let's see. EA does intersect with AF, so that doesn't work. ED does not intersect with AF. And is AF ever going to cross ED? No, because ED is kind of in the front, and then AF is behind it. So I would say ED would be an example of a skew line to AF that contains point E. EJ is the 3rd line coming out of point E, but that would be parallel to AF, not skew, so that would be it. Just the one answer. Lines perpendicular to AF and containing point E. Well, if I assume that these 5 shapes forming the central part of this shape, this figure, this solid, if I assume that this is a rectangle and that's a rectangle and the bottom's a rectangle and these other 2 sides are rectangles, then I can assume that these corners are 90-degree angles. So it seems to me like that is a fair assumption, since this pentagon does look like a regular pentagon and these lines seem to be going straight back. So is there a line that's perpendicular to AF and containing point E? Well, probably, because this flat surface here is a rectangle. I can say that EA would be perpendicular to AF because it would form the corner of the rectangle. I don't see any other lines coming out of E that would be perpendicular to AF. EJ would be parallel and ED would be skew. And lastly, planes parallel to plane FG. I'm assuming this would be G back here because I don't see a G anywhere else. FG H. Huh. Well, I don't see an H either. Well, let's assume that this plane is the back plane, FJI. So this is basically the back wall of this solid back there, and containing point E. So a plane that would be parallel to the back pentagon would be the front pentagon, wouldn't it? And the front pentagon does contain point E, so it would be a good answer if this is the true question. So I'm going to go ahead and say that the front panel is my answer. So I'm going to say plane, and then I can choose any three of these corners, any three vertices on the front pentagon plane. I'm going to say A, B, C. And lastly, just talking a little bit about parallel lines. If there's a point, if there's a line and a point not on that line, there's exactly one line. Through that point that is parallel to the first line. So here's the first line. They're basically saying if you draw a line and then you draw a point that's not on that line, there's exactly one line that would go through that point, one and exactly one, that would be parallel to the first line that you drew. Postulate number 14 is very similar to that. If you draw a line, it says, and then you draw a point not on that line, there's going to be exactly one line that goes through that point that is perpendicular to the first line that you drew. 90 degrees.